The human fascination with time travel is nothing new. For centuries we've gazed at the stars and wondered about the mysteries of the universe, including the tantalizing possibility of moving through time. From H.G. Wells's The Time Machine to the iconic DeLorean in Back to the Future, the idea of journeying through time has captivated our imaginations for centuries. These stories have inspired countless generations to dream about what lies beyond the constraints of our current reality. The allure of time travel is not just about the adventure, it's about the possibilities it represents. Imagine being able to witness historical events firsthand, or glimpse into the future to see what awaits humanity. These thoughts have fueled our collective imagination and driven us to explore the boundaries of what we know. But what was once relegated to the realm of science fiction is now becoming a subject of serious scientific inquiry. Researchers and scientists are delving into the complexities of time, space, and the very fabric of reality to understand if time travel could ever be more than just a fantastical notion. Could time travel, once a mere fantasy, actually be possible? This question has moved from the pages of novels and the screens of movies to the forefront of scientific debate. As a physicist, I find myself drawn to the edges of our understanding, where the known universe blurs with the vast unknown. The quest to understand time travel is not just about science, it's about pushing the boundaries of human knowledge and curiosity. And few topics are as tantalizing, as potentially paradigm-shifting, as the concept of time travel. The idea that we could move through time as easily as we move through space challenges everything we know about the universe. While it remains a topic shrouded in mystery and theoretical speculation, recent advancements in physics, particularly in the fields of quantum mechanics and relativity, have opened up intriguing possibilities that were unimaginable just a few decades ago. These advancements suggest that the fabric of time may be more flexible than we once thought. The journey to unraveling the secrets of time travel is not for the faint of heart. It requires dedication, perseverance, and a willingness to explore the unknown. Scientists around the world are working tirelessly, often late into the night, driven by the hope of making groundbreaking discoveries. It demands a willingness to challenge our most fundamental assumptions about the nature of reality itself. Theories must be tested, and new ideas must be explored, even if they seem impossible at first glance. But the potential rewards are immense. If we can crack the code of time, we may unlock secrets of the universe that have remained hidden since the dawn of time itself. The implications for humanity are profound, offering new ways to understand our past, present, and future. If we can crack the code of time, we may unlock secrets of the universe that have remained hidden since the dawn of time itself. The journey is long and arduous, but the destination could redefine our understanding of existence and our place in the cosmos. To grasp the possibility of time travel, we must first abandon our intuitive understanding of time. Our everyday experience tells us that time flows in one direction, from the past, through the present, and into the future. This linear perception of time is deeply ingrained in our consciousness. We see it in the way we live our lives, plan our days, and even in the way we remember our past. We are constantly moving forward, never backward, and this forward motion seems as natural as breathing. This linear perception of time is deeply ingrained in our consciousness. We measure it with clocks and calendars, and we structure our lives around its relentless march. But what if this understanding is fundamentally flawed? However, Albert Einstein's groundbreaking theory of relativity shattered this Newtonian view of a static, universal time. Einstein revealed that time is not absolute but rather relative. It is intricately woven together with space to form a four-dimensional fabric known as space-time. This revelation was nothing short of revolutionary. It meant that time could stretch and compress, depending on the speed at which one is moving, and the strength of gravitational fields. It is intricately woven together with space to form a four-dimensional fabric known as space-time. This fabric can be warped and stretched by massive objects like stars and black holes. Imagine a bowling ball placed on a trampoline. The ball creates a dip in the fabric, altering the path of a marble rolling nearby. Imagine a bowling ball placed on a trampoline. The ball creates a dip in the fabric, altering the path of a marble rolling nearby. Similarly, massive objects in the universe distort the fabric of space-time, influencing the passage of time around them. Similarly, massive objects in the universe distort the fabric of space-time, influencing the passage of time around them. This warping of space-time has profound implications for our understanding of time. Time slows down in stronger gravitational fields. This means that time passes slightly slower at sea level than it does on a mountaintop, where the gravitational pull is weaker. Time slows down in stronger gravitational fields. This means that time passes slightly slower at sea level than it does on a mountaintop, where the gravitational pull is weaker. While this difference is minuscule in our everyday lives, it has been experimentally verified using atomic clocks. This means that time passes slightly slower at sea level than it does on a mountaintop, where the gravitational pull is weaker. While this difference is minuscule in our everyday lives, it has been experimentally verified using atomic clocks. These precise instruments have shown that time indeed ticks at different rates depending on the gravitational field. While this difference is minuscule in our everyday lives, it has been experimentally verified using atomic clocks. These precise instruments have shown that time indeed ticks at different rates depending on the gravitational field. This malleability of time, as revealed by Einstein, opens the door to the tantalizing possibility of manipulating time itself. This malleability of time, as revealed by Einstein, opens the door to the tantalizing possibility of manipulating time itself. If we can understand and harness these principles, the concept of time travel might not be as far-fetched as it seems. The future of time exploration holds endless possibilities, limited only by our imagination and our willingness to explore the unknown.
Quantum entanglement is one of the most mind-boggling phenomena in physics. When two particles become entangled, their states are interconnected, no matter the distance between them. This means that a change in one particle instantaneously affects the other, defying our traditional understanding of space and time. It's almost as if information can travel faster than the speed of light, which according to Einstein's theory of relativity should be impossible. This has led some scientists to speculate about the potential for quantum entanglement to facilitate some form of time travel or instant communication across vast distances. While we are still in the early stages of understanding these phenomena, the implications are, without a doubt, profound.
The concept of wormholes, or shortcuts through space-time, has long intrigued scientists and science fiction enthusiasts alike. According to Einstein's theory of general relativity, wormholes could theoretically connect distant points in space-time, allowing for rapid travel between them. If such structures exist, they could offer a means of traveling not just across space, but also through time. However, the existence of wormholes remains purely hypothetical at this point. Their stability, traversability, and the energy required to create and maintain them are still subjects of intense debate and research. But if we could harness the power of wormholes, the possibilities for exploration and understanding of our universe would be, well, truly limitless.
So, the idea of changing the past is, something that has fascinated scientists and thinkers for centuries. It's a concept that has been explored in countless books, movies, and theories, and, well, pretty much everyone for a long time. The concept of time travel, especially to alter events that have already occurred, brings up a lot of paradoxes and questions. It's not just a matter of science fiction. It's a topic that delves deep into the realms of physics and metaphysics. If you were to go back and change something, would it create a new timeline? This idea of branching timelines suggests that every decision we make creates a new path, a new reality, or would it erase the existing one? The notion of erasing a timeline brings up the question of what happens to the memories and experiences of those who lived in that timeline. These are honestly not just scientific questions, but philosophical ones too. They challenge our understanding of existence, reality, and the nature of time itself. One of the most famous paradoxes is the grandfather paradox. This paradox questions the very fabric of causality and existence. If you travel back in time and, say, prevent your grandparents from meeting, would you cease to exist? This creates a loop of cause and effect that seems impossible to resolve. And if you never existed, who went back in time to stop them from meeting? This paradox is a classic example of the complexities involved in time travel theories. There are theories, of course, that suggest multiple timelines or, parallel universes might be the answer. These theories propose that every possible outcome of every event exists in its own separate universe, but we still have so much to learn and understand before we can even think about changing the past. the study of time, its properties and its implications is still in its infancy. As we continue to explore and understand the universe, who knows what we might discover about the nature of time and our ability to influence it. Perhaps one day, with advancements in technology and a deeper understanding of quantum mechanics, we might find a way to navigate the complexities of time. Until then, the idea of changing the past remains a fascinating and tantalizing mystery.
At CERN, we're pushing the boundaries of what we understand about time. Our experiments with the Large Hadron Collider are revealing new insights every day. It's like we're standing at the edge of a vast unknown frontier, ready to step into the future.
Time travel isn't just about the science, it's also about the ethical implications. We have to consider the consequences of our actions in the past and future. It's a journey that requires immense responsibility and, honestly, a deep sense of morality.
The future of time travel holds endless possibilities. We might be able to explore alternate realities or even parallel universes. It's an exciting prospect, and who knows, maybe one day we'll be able to navigate through time as easily as we do through space.
As we stand on the brink of new discoveries, the dream of time travel feels closer than ever. The journey is far from over, but with each step forward, we inch nearer to turning this dream into reality. The question remains, are we ready for what lies ahead?